All right, guys, so for today, we are going to be talking about the extreme value theorem and local max and min values. All right, so to start it off, the extreme value theorem is basically a theorem that states that for any function, let's just do f of x, on a given interval a to b, there will be a absolute min and absolute max on that function. Now for this function, one of the conditions is that it has to be continuous. So it has to be continuous through a to b. So let's just draw a function here. All right, so let's just say this is our a value and this is our b value. Let's just draw lines up here. And these aren't asymptotes, it's just the range of values that we're gonna have. Okay, so there's our function. So let's just say, so this right here is going to be our maximum value. And this right here is going to be our minimum value. So let's just call this maximum value D, and let's call this minimum value C. Now, the proper notation for this exact theorem is that f of C is going to be less than or equal to f of x, which is going to be less than or equal to f of d. And this is going to be true for any x value in between this interval of a to b. And that's basically the way this theorem works. And it'll work for any function. So it'll be the same a to b if it was a flat line. So if it's a flat line, then basically the max or min can be taken at any point on this line. And you can see that it's going to be equal to this value f of c and this value f of d, which could be on any point of this line. It could be anywhere in between the interval. And if you take another function, something like this, which is a to b, same right here, because this can equal, it's a closed interval, it can equal these values a and b, and this will be your min, and this will be your maximum. And this formula is basically for any point C in between A and B, and at the endpoints, f must have a low and a high value over this graph. All right, so the second part of this is going to be local max and min values. Okay, so for this, it's basically if you had a function and let's just say it's that. All right, so it's on an interval from 0 to 5. So this is going to be 0 and this is going to be 5. Okay, so here is going to be our absolute maximum value, because this, on this interval of the graph, this is our highest point of the graph. But this is another bump in the graph. So this is going to be our absolute, that's going to be our local max of the graph. And this right here, so this is not our lowest point of the graph, but it is a point where the slope is equal to 0. So if you drew the tangent line, the slope is going to be 0, which is the same for these. So it's going to have a critical number at that point. And so this is going to be the local min of the graph. And these points look rather similar, but if you just drew all the way to 0, this will be our absolute min of the graph, because this, in this interval, is going to be the lowest point of the graph. And so basically anything can be a local max or min over a certain interval of the graph. And the only different conditions for a local max or min is that it has to be continuous through that point. So it has to be a continuous function through that point. And it also has to be a curve. So it has to be concave up or concave down based on just whether it's a local max or it's a local min. So for this point, as you can see, it's an absolute min, but it doesn't have a side to it. So this just goes on and it doesn't have a limit for this side of the graph. And so an absolute max or min can have only one side of the graph as it approaches this value right here. But a local max or min has to have it approaching from both sides, because here you can't take the derivative. It only has one side. Similar to a graph like this, it's a corner, so you can't take the derivative at this point. But here, on the other hand, you can take the derivative at either point, and the limit as it goes from, let's just say this value is 3. So the limit as x goes to 3 minus, and the limit as x goes to 3 plus are going to be the same value. And then if you have the derivative of the graph, so if you have the derivative function f prime of x, this right here, 3, is going to be a 0 for that value. So when f of x is equal to 0, x is going to be equal to 3. And so as it approaches from either side, that is what determines it as a local max or min value. And I hope this was helpful for anyone who's trying to study this section, and hopefully we don't fail the final.